All right, everybody, we're ready to get to the last module, 4.5, and we're ready to divide a polynomial expression by a monomial. So let's think, what does polynomial mean? Polynomial means many monomials connected by addition and subtraction. And we're going to divide that polynomial by a one term, a monomial. So if you look at your slide, we're going to start with 3x squared plus 6x minus 9 divided by 3. The first problem is you've got to think about concepts. The fraction bar means to do division, and we've already discussed in order to do division, you must be connected by what operation? That's right, multiplication. Well, 3x squared plus 6x minus 9 is not connected by multiplication. So you cannot start jumping in and dividing. So you're going to say, well, what do I do? Well, we have to think about what this expression is telling us. Do you see how the fraction bar goes all the way across? So the question is, who are we dividing by 3? Which term? Are we dividing the first term, 3x squared by 3? Are we dividing the middle term, 6x by 3? Or are we dividing the last term, negative 9 by 3? Well, if the fraction bar goes all the way across, people, that means we're dividing all those terms by 3. So what you need to do is rewrite this. You need to rewrite it not as one division problem, but as 3. In your numerator, you have a trinomial, 3 terms. And when you say you're dividing by 3, you're dividing each of those terms by 3. So that trinomial is going to break up into 3 division expressions. And that's what I expect you to do, rewrite it. So what I'm saying is I'm asking you to take 3x squared divided by 3, plus I'm asking you to divide 6x by 3, minus I'm asking you to divide 9 by 3. Once you rewrite it now, we are connected by multiplication because 3x squared is a monomial. 6x is a monomial. 9 is one term, it's a monomial. And now we can divide each of those individual monomials by 3. And here we go. 3x squared divided by 3 would be 1x squared. Do we need to write 1x squared? No, we've already discussed this. You never write in algebra a coefficient of 1. So we just write good old x squared. Then we're going to bring down the plus sign. What's 6x divided by 3? Oh, that's 2x. Great. Then we're going to bring down the minus sign. What's 9 divided by 3? Oh, that's 3. So the only way to divide a polynomial, many terms, by a monomial, one term, is to physically rewrite it as many little divisions. And when you write it as many little division expressions, you're dividing monomials. So our quotient here is x squared plus 2x minus 3. Now what's great is we could check and see if that's correct. Think about, again, 3rd and 4th grade math. When the teacher said to you, what's 12 divided by 3, you said 4. And then the teacher said, well, how can you check that? And you said, okay, let's go backwards. The opposite of division is multiplication. So if you said 12 divided by 3 is 4, that meant 4 times 3 has to be 12. Well, the same thing's true in algebra. If you're saying your answer was x squared plus 2x minus 3, if you really want to know if that quotient's correct, do the opposite. Multiply back by 3 each of those terms and see if you get back to my original expression. So if I take x squared and multiply it by 3, yep, I get back to 3x squared. If I take the positive 2x and multiply it by 3, I get back to the positive 6x. If I take that negative 3 and multiply it by 3, I get back to negative 9. So you can always check in algebra if you divide it correctly. Because if you go and take your quotient, your answer, and multiply it by what you divide it by, you should get back to your original expression. All right, we're going to try some in the next video. I'll see you then.